So I hope you are able to see my screen. The first opening slide, reliability and QoS in IoT healthcare.
Yes, sir, you are visible, audible. So now PPT is also very well seen, sir.
Thank you so much. So this is the opening slide, and here I'll be discussing about the reliability and QoS in IoT healthcare. Yesterday we have seen that what is IoT healthcare and what is Internet of Medical Things. So in today's talk, I'll be discussing more about the reliability and QoS aspects of IoT healthcare or Internet of Medical Things. So in this, we have already discussed the aspects related to the security and how to take care of those aspects. Now, today we will be talking about reliability and quality of service. So first of all, let me tell you that security and reliability, they go hand in hand, whereas quality of service is a little bit different from reliability and security. So we'll just see what are those differences and how to what are different kind of issues that come in reliability and QoS in IT healthcare, and maybe if there are some possible ways how they can be taken care. So first of all, let us see what are the security breaches can be there. What all security breaches can be there in IoT healthcare. Now, in this, we'll be talking about prevention and mitigation of or other defenses again several possible security attacks, and threats can be there in all IoT applications in healthcare. As I told you in previous talk that IoT has one of its major application in healthcare. We were talking yesterday that almost 70% of IoT applications are there in healthcare nowadays. So Internet of Medical Things or IoT healthcare is nowadays one of the most biggest taker of the IoT revolution. The privacy of healthcare IoT application users and other operational reliability of healthcare applications must be granted. Reliability requirements are higher in healthcare IoT than for other IoT systems because of the health consequences of device faults for users of healthcare IoT devices. So the damage here can be bigger if the reliability or security is tampered or hampered. Security and reliability are, of course, interrelated. Low reliability decreases IoT device availability, which is fundamental security requirement. So if an IoT device is not reliable, then there is no use of having it. So it affects the availability of the device, and this is the basic security requirement. Security incident which disturb, change, or stop the operation of an IoT device also decreases the reliability of the IoT device. So security and reliability of healthcare IoT systems, as well as the privacy of the user of these systems, provide the safety for the user and environment of these systems. So it's right now looking very simple that security and reliability, they are interrelated, and if security is hampered, then reliability is also affected, and there are different security attacks can be possible and blah blah blah. But actually, when we discuss the kind of attacks then that can be there and the impact that they can cause on an individual, we will be just it will be just scaring for all of us to know about all those things. Safety is also safety is also related to security and reliability, and we always want that our systems, healthcare systems, should be safe. So safety in this context, protection of the user and the environment of healthcare IoT systems from any possibly occurring system failure. So this is just to get an idea of how reliability is connected to the security and safety. So the system has to be very reliable if you want to use it for your own healthcare. There can be several type of security threats to IoT systems. Now, if you want to categorize these security threats in form of, on the basis of the kind of attacks, then these attacks can be physically destroying an IoT device fully or partly, disturbing an IoT device by modifying the data received by the device in order to prevent correct operation. Yeah, this is very, very scary. The data which is going and it is being tampered will definitely, it can have very serious effects on a person's health. Reprogramming an IoT device by changing the code of the device is also very, very scary, and it can have very bad effects when they are, excuse me, class is going on. There is a class going on. Causing denial of service for an IoT device which eavesdrop the network connected to an IoT in order to learn sensitive health information. Now, if you talk of consequences that can be there due to these security attacks, these consequences can be in form of information disruptions. These disruption attacks are interruption, interception, modification, fabrication, or replay of the information or data which is there in the IoT devices when it is being communicated through a network. IoT device property comprises IoT device compromises can be there. IoT devices are compromised by theft of passwords, cryptographic keys, other sensitive user data, by tampering the device hardware, by exploiting device software vulnerabilities. So these can be the IoT device property compromises that can be there for a particular type of IoT device. Network property compromises. So there are three basic things here which have come into picture. One is IoT device, one is network, and one is data. So network property compromises are protocol specific, such as deviation from standard protocols, or layer specific, such as exploits of protocol stack vulnerabilities. So basically, there are three types of consequences of security attacks. Either information or the data is compromised, or the IoT device properties are compromised, or no network properties are compromised. Now let us have a look at some examples of these security threats. One by one, we'll discuss maybe a dozen of examples, and we'll just see that how difficult or serious the situation can be if there are security threats. Now just imagine that the body of a person can be accessed and manipulated, causing injuries and worse through unauthorized access of physical sensing, actuation, and control system, that is such as implantable or non-implantable medical device. Now, suppose there is a biomedical device or an IoT device implanted in your body, and it has to suppose control the release of a particular say medicine inside the body, and imagine it is being controlled by somebody who is not authorized to do so. Just imagine the kind of situation he can create for you. Healthcare providers can improperly diagnose and treat patients based on modified health information or manipulated sensor data. So this is another difficult situation where a person, a device which is sensing certain parameters, and when the data gets hampered or it gets tampered by somebody, and it is sent to the healthcare worker, and based upon that tampered or manipulated data, he tries to write a prescription for somebody. So it will be a very difficult situation for him. Malicious parties can steal identity and money based on leakage of sensitive information such as personal health information. So this health information is very, very personal, and based upon this, they can steal your identity, because if your health conditions are known to somebody, then it's as good as having the identity theft for an individual. And in the same way, money can also be created based upon this information. Leakage of personal health information can occur by aggregating data from many different systems and sensors. Unauthorized tracking of people's location can occur through usage pattern tracking based healthcare asset usage time and duration. So this is also a kind of a privacy attack on somebody, that wherever an individual is going, someone else who is not authorized to know is knowing where an individual goes. Unauthorized tracking of person's behavior and activity can occur through examination of location-based sensing data that exposes pattern and allows analysis of activities often collected without explicit notice to the target person. Now, these last two points, you know that. Just a second. Give me a moment, please. सुपरवाइजर के साइन नहीं किया इसका. I'm so sorry for this. Okay, so last 2 points, you can see that this is something which we are already experiencing, and every one of us knows that already our location, behavior, activities are being tracked through the mobile phone that we are using. Anyways, so this is actually a security breach or security threat, but we are already signing a kind of contract with the apps that we are using, who are taking all these informations. Unlawful surveillance through persistent remote monitoring capabilities offered by small-scale IoT devices. Inappropriate profile and characterization of individual can be created through examination of network and geographical tracking and IoT metadata. Vandalism, theft, or destruction of IoT assets that are deployed in remote locations and lack physical security controls. Other examples can be ability to gain unauthorized access to IoT edge devices to manipulate data by taking advantage of the challenges related to updating software and firmware of embedded healthcare devices. Ability to create botnets by compromising large quantities of IoT edge devices. Ability to impersonate IoT devices by gaining access to keying material held in devices that rely upon software-based trust stores. So these are some of the kind of security threats and examples of security threats that one can face when they are having an insecure IoT system for healthcare specifically. Now, let us see what are the IoT security and reliability requirements. First major requirement is confidentiality. Unauthorized parties should have no access to medical information. Second is integrity. The data in transit and stored data cannot be altered by adversaries. Third is non-repudiation. That is, sending and reception of data cannot be denied. Fourth is data freshness. Replay of old data is excluded. Third is resilience to attack. There must be no single point of failure, and the system should adjust itself to node failures. Data authentication. Authentication of retrieved addresses and object information is a necessity. Access control is another requirement, in which information provider must implement access control on provided data. Client privacy is also one of the major reliability requirements. Only information provider should be able to infer from observing the use of lookup system. Fault tolerance and self-healing. A security scheme should guarantee health service continuation even in presence of battery energy ending or a fault in an IoT device. So, based upon these reliability and security requirements, let us see what are the reliability and safety aspects of medical IoT devices. So, healthcare IoT systems have higher reliability requirements than most of other IoT systems because failures and malfunctions have direct consequences for human life. Measures of how reliable a system is are availability, mean time between failures, and device lifetime. The measures availability and device lifetime may include downtime after which correct device operation continues. The traditional telecom industry requirement for hardware reliability is 99.999% availability, for which an expected annual downtime is 315 seconds. And for software reliability, 99.95% availability, for which the expected annual downtime is 4 hours, 22 minutes, and 30 seconds. For some healthcare IoT devices, like heart rate monitors for patients in ICUs, even short downtimes are unacceptable, and therefore MTDF is a proper reliability measure for such devices. Another common hardware reliability prediction methodology is based on physics of failure, where data from failure tests on a large number of samples and from numerical finite element analysis is used to predict device failure rates in the field. In a methodology for device hardware and software reliability prediction, under some uncertain use conditions is proposed in derivation of probabilistic estimate of overall device reliability. The methodology is illustrated by estimation of the impact of temperature variation on the reliability of two components type, solder joint interconnects, and fans in the networking device. The methodology is extended to cover almost software and networking devices by capturing interaction between hardware, resource consumption, processing rate, memory of device software, and the delay between software and hardware updates. Software failures can occur for reasons like bugs, vulnerability in software version, software hardware incompatibility, and many other such reasons. Now, in this, whatever we have seen so far, one thing we have just understood that the device, IoT device, is an important aspect which should be very reliable, and there should be almost no chance of its failure. In addition to this, if you want to have a reliability of an IoT healthcare system, then the network infrastructure should also be very, very reliable, because it's the network infrastructure which is carrying all the information from an IoT device to the healthcare service provider. And therefore, the data which is being transferred from an IoT device to the healthcare service provider is also equally important, because based upon that data, the healthcare service provider or the doctor is taking the decision on what the course of treatment should be for a particular person. So reliability and safety aspects of medical IoT networks are also very, very important. In fail stop service, in fail stop, a device stops operating and restart is difficult. In fail safe, a device stops operation and enters a safe state, or device operation is safely degraded. In fail loud, an alarm is triggered by the stoppage and change of device operation, and in fail quiet, no alarm is triggered. So basically, these four types of situations can be there, where in which a medical IoT network can face. The development and maintenance of reliable and safe software for medical IoT devices and for other medical devices was standardized in 2016 with an amendment in 2015. Software safety classes related to software failure are defined as follows. There is a class A, in which no injury or damage to the health is possible. So there can be hazards that can be class A hazards. Class B hazards, no serious injury is possible. And class C is the most serious one, where death or serious injuries are possible. Now, in this standard, the general requirements are defined for software development, including development planning, requirement analysis, architectural, detailed design, implementation and verification, integration and integration testing, and software system testing and release. Then software maintenance requirements are also there. Software risk management requirements are also there. Here this risk is defined as the combination of probability of occurrence of harm. So this harm can be physical injury, damage, or both to the health of people and damage to property or the environment and the severity of that harm. Then there are requirements defined for software configuration management and software problem resolution. So for safety of class C standard, for safety the class of C, the standard must be applied to 100%, and for class B it should be applied to 93%, and for class A it should be 43%. So these standards should be 100% applied for class C software failure hazards. Now let us discuss some future outlook in security and reliability. Here there are important future directions for healthcare IoT which are given, that are sufficiently lightweight for applications using wearable technology. They should utilize the temper resilience of blockchain technology. So these are future directions in which healthcare IoT should go for making it more secure and reliable. Deployment of blockchain technology may be proposed for improved reliability of the medical devices. During manufacturing, a hash of the unique device identifier is stored in the blockchain along with other pertinent information such as company name. The blockchain information is updated with patient data, hospital, doctor, emergency contacts, and patient care directives. A series of smart contracts can autonomously notify the patient and the providers about device service needs, about approaching battery expiration, and about detected 174 patient health irregularities. A smart contract sending prevention maintenance information to the patient and to the provider thus reduces the risk of catastrophic device failure. So these are some of the issues that are faced during security attacks and that affect the reliability of a healthcare system using IoT. In addition to this, there are ways that are suggested to take care of these security attacks and reliability aspects. And in future, maybe there may be some blockchain technology which may be introduced at various points to make it more secure and reliable. So with this, we have now understood what is the difference between reliability and quality of service. So reliability is something which is bare minimum thing which we are expecting from an healthcare device in using IoT. Security is also something bare minimum. Now next comes is quality of service. So let us discuss quality of service in IoT healthcare. So by increasing intelligence in health services, people's quality of life has improved and access to emergency medical services and care for patients and elderly will be faster and easier. We have already seen yesterday that how this usage of IoT in healthcare or Internet of Medical Things have reduced the number of visits to a healthcare facility. People have become more and more cautious nowadays, and they have started using these devices to monitor their health parameters so so that whenever there is something unusual, they are able to pay a visit to the doctor. The IoT services can provide healthcare to a new generation of skilled services that are highly acclaimed. However, there are challenges in this area. One of those challenges includes assurance quality of service due to high volume of information. The existence of programs that produce large amount of real-time data in terms of velocity and variety has turned this into a big data problem. So already there are so many connected devices around the world that are measuring and monitoring the health parameters of individuals across the world. So this is actually producing a large amount of data, and this has now become a big data problem. And for solving this the big data problem and to provide good quality of service, there is introduction of cloud of things or cloud IoT, which has been introduced. So to overcome these challenges, the researchers recommend the integration of the cloud and Internet of Things. Due to this, the patient monitoring system is supported by the recent developments, mainly by cloud computing and IoT paradigms. So the integration of two paradigms contributes significantly to the provisions of more quality of service. This is known as cloud of things or cloud IoT. The paradigm, the cloud of things services is available to the user through IoT devices and by multiple providers, including clouds. The goal is to use the integration capabilities of these two paradigms in providing services. Features that help consumers get better quality of services. The cloud of things allows the provision of integrated service at better speed and accuracy. For example, intelligence in health, smart cities, and intelligent transportation. So here will be more focused towards the healthcare usage or application of cloud of things. In addition to this cloud of things, basically this integration of cloud and IoT, this also reduces the cost of implementation of these systems, since most of the information, data, and software is there on the cloud. So to provide efficient service delivery, the need to provide a certain level of service quality is guaranteed from both the cloud and IoT. Heterogeneous networks should support different type of data and services in the integration of the cloud and Internet of Things. Therefore, these networks should have flexibility to support all type of data in accordance with the requirements, along with the support of quality of service. The quality of service is one of the major challenges in the integration of the cloud and the IoT. Despite high heterogeneous resources and services in this environment, the quality of service is very difficult to guarantee. Now we talk of intelligence, because since all this IoT and healthcare and all this is just to give more power to the healthcare workers and to the machines. So since there is a lot of data which is flowing from one side to other, maybe from a patient to a physician or from a healthcare facility to a patient, there is going to be a vast intervention of the machinery, the software and hardware in between to analyze and clean the data. So this intelligence is a basic requirement of these smart IoT healthcare devices. Here the intelligence is used to describe everything, including health, banking, and cities. So if there is intelligence in health, it will be called as smart health, smart banking, smart cities. So wherever there is an intelligence associated, we say it is smart. So intelligence, in fact, takes an infrastructure or even transaction, guarantees its connection, analyze its data, and will ultimately make it more efficient and effective. Intelligence is a layer of insight and decision and beyond interactions between objects. The ability to acquire, analyze, and decide in more complex and flexible ways leads to increased effectiveness that helps to maximize the potential of energy, transportation networks, production lines, healthcare services, supply chains, and health data. In addition, this intelligence provides more information to humans and provides a deeper insight that helps them make better decisions, better manage their health, and use energy and resources more efficiently. In this concept of e-health, the concept is based on the link between a health organization and patient through machine-to-machine communication. Electronic health services are defined as use of internet and other related technologies in the healthcare to improve access, efficiency, effectiveness, and quality of clinical and business processes by organizations. Healthcare providers, doctors, patients, and consumers are trying to improve the health of patients. E-health is one of the key concepts for improving today's healthcare, that is the usage of ICT in care. Also, e-health according to WHO definition is the use of information and communication technology for health. Examples including treating patients, conducting research, educating the health workforce, tracking diseases, and monitoring public health. Now, since a lot of data is being generated, so there is a need of taking care of this big data problem that arises due to generation of such a vast amount of data from different machines which are positioned at both patient as well as healthcare industry side. So big data here has the ability to help healthcare organization to equip providers with the necessary equipments of healthcare. The IoT healthcare devices will bring medical data into signals and or to images. These big data obtained from IoT will require detailed analysis for exact diagnosis. So there are different algorithms which can be there to analyze the data so that exact and accurate diagnosis can be done. An unprecedented level of real-time data can be obtained by smart systems. Today, healthcare systems are rapidly gathering clinical data and rapidly increasing health records available electronically. Big data are used in the implementation of following healthcare. First, the patient-centered framework based on big data frameworks reduces the level of healthcare, impact of disease, and reduction in pre-admission rates. Physiological human analysis with big data analysis to develop robust and valuable solutions in medicine. So in a remote patient monitoring system, with recent developments is mainly supported by two technologies. First is cloud computing and Internet of Things. And here, to increase this quality of service, both the technologies are combined. The remote monitoring programs that use technological developments in IoT, semantic web, analysis of data and cloud computing serve as an appropriate alternative to traditional surveillance techniques. However, such programs produce a large volume of real-time data in terms of volume, velocity, and variety, making it a big data problem. Therefore, how can it combine and analyze such information with the history of patient data to obtain meaningful diagnostic suggestions in acceptable frames with respect to quality of service requirements? Let us see now the main stages of a health monitoring program. So first of all, a local gateway sends sensors data to a process and cluster string that runs inside the cloud. Sensor data is processed by the threaded query engine and divided into two parts, one with the event and one without an event. An eventful data is determined using meaningful labels and are reprocessed to determine the patient's condition. These data are then sent to a virtual machine containing a copy of knowledge base, and its data is analyzed to extract more text information about the patient's place, time, day, etc. Outputs of outputs are ultimately sent as warning on available devices that are tailor-made for healthcare goals such as specialist physicians, emergency services, local healthcare centers, etc. Now let us see what are various challenges in quality of services of cloud of things. The challenges faced by cloud services will be divided into two categories: resource management and software engineering based challenges. The key challenges are managing resources, delivering quality of service to users, to utilize and relocate resources, and difficulty reaching requirements of service level agreements in terms of cost effectiveness of the system provided and the monitoring of resources. The main challenges and issues in the development of applications are discussed using software engineering services such as confidentiality and integrity, reliability and availability, and QoS monitoring. The cloud computing challenges of software engineering include providing service quality and elasticity for expanding applications of cloud, lack of application of management, lack of approaches for expanding cloud services optimization with different QoS criteria such as cost and performance. Now, let us discuss the challenges for the quality of service in IoTs. So, before this, it was cloud of things. So now it is IoTs. The energy constraints are big issues in IoTs. In addition to power constraints, there are other issues such as bandwidth, buffer size, available memory, node processing capabilities. The limitation of energy in healthcare systems has a significant impact on the quality of service presented. The traffic load on the IoT is unbalanced because the sync node receives data from large number of distributed sensors in the environment. This unbalanced traffic load on service quality also affects the entire e-health network. The sync node receives data from large number of sensor nodes. Among all these data, there are some additional data. These additional data will waste a lot of energy that affect the quality of service. So it is important to identify that what data is useful, what data is not useful. Scalability is an open issue for IoT applications, and applications should work continuously even when more users are added to the network. Error tolerance is also one of the challenges. In this, failure of node or failure of connection is also important, an issue that delivers quality of service in wireless networks. Heterogeneity of IoT factors also affects quality of service. Applications that will use several receivers that require different types of traffic patterns, this affects the quality of services in IoT. And multimedia programs such as video chat, SMS, voice chat, and various other types of delays sensitivity show that it is difficult to provide these services with minimum delay. Now let us see the challenges for the quality of service in remote healthcare. The Internet of Things is an intelligent technology that uses resources efficiently and synchronizes physical objects with the internet to form physical cyber systems. The smart devices play an important role in IoT healthcare programs. Medical devices with IoT features are independently linked to their basic capabilities, such as health data collection, processing, and communication. The existence of programs that generate a large amount of real-time data in terms of speed and variety makes this a big data problem. Therefore, how they combine and analyze such information with the history of patient data to obtain diagnostic suggestions that are meaningful in acceptable frames with respect to quality of service is one of the biggest challenges in this field. Then there can be specific techniques and technologies for analyzing and evaluating data. This is required due to high increase in volume and data velocity and types of healthcare sensors, technologies. They are required to analyze and evaluate data. These challenges are in the area of healthcare, where data is significantly symbolic of medical research, body remote sensor, and electronic record produced in this area. These constraints can negatively affect the care of the patient, particularly with regard to time alerts and diagnostic suggestions. Also, in remote control applications, the use of semantic web technologies generally limit the use of sensor data with conceptual information about sensors, like type, location, etc., and the patient's environment, such as location, time of day, etc. While joining the textual information makes the system more intelligent and allows for better decision making based on variety of different factors. It generally does not consider the patient's health, which can have harmful consequences, especially in the elderly who are more likely they are exposed to multiple illnesses. For more comprehensive knowledge to make informed decision, sensor data should be used to study the past medical and medical situation of the patients. Only relying on sensor information can be dangerous because critical environment may be lost or ignored. The emergence of big data and IoT on one hand and on the one hand and growing demand of smart applications on the other have caused significant challenges in the efficiency of the arguments, real-time and scalable applications. It is understood that using of cloud-based technologies, we can implement scalable reasoning techniques that match IoT constraint in real-time applications. The combination of cloud and semantic technologies for IoT sensor data analysis can be used in importance such as real-time data analysis to indicate hidden implicit information in large volume of data, personal protective support and better informed decision making, accessibility of patient information to physicians and health providers, and automate the process of analytics and decision making. So this data can be uh, made accessible to physicians and health providers as well as to the software who can intelligently help the service providers and physicians to make the decisions based on the information received through big data. Despite highly heterogeneous resources and services in the cloud of the ecosystem, it is very difficult to guarantee quality of service in this environment. Since COT includes multiple computational paradigms such as IoT, cloud, and big data analysis systems, designs and developments of applications using COT is very difficult to guarantee US criteria. But it is at the same time very, very important because it is the question of one's health and life. So there is a deficiency of standardized methods for end-to-end service quality, that is between the end user, IoT, and cloud. And these shortcomings can be overcome by QoS aware. Complexity of integration of different layers of cloud and Internet of Things, and existence of a number of QoS constraints and parameters in each layer can be a serious challenge to the quality of service. So there are a lot of challenges in the quality of services in IoT healthcare, especially in remote healthcare. And all these challenges must be identified well in each scenario so that they are taken care. Otherwise, the situation can be very, very critical in all cases. So here there is a possible framework which can be proposed to guarantee the quality of service applications in healthcare. The need of monitoring measure workloads, data volume, data velocity, data variety, source data, and combinations query searches are different through the framework of big data processing systems for reasoning and ontology so that appropriate descriptive workload model can be developed. Now the biggest challenge is how to collect and integrate the monitoring data from all big data processing frameworks and hardware resources to facilitate manager and understand SLAs and QoS at the level of application without the need of understanding the total complexity of platform. Therefore, there is a need to investigate the quality of service parameter in cloud dimensions and network dimensions to determine overall quality of service in health applications. In fact, the complexity is that there is a number of X parameters from the network and number of Y parameters from the cloud, which is challenging to determine quality of service for a real-time healthcare application. We define QoS criteria as QoS is a function of quality of service at cloud, quality of service at network, location, battery, and the total number of QoS parameters both at cloud and network dimensions. Therefore, from this equation, it can be seen that end-to-end quality of service is multidimensional and complex issue that must be considered carefully. So we reach to a conclusion here about the quality of service challenges and issues and possible solutions, that the integration of cloud and Internet of Things represent a big leap ahead for the future of the Internet. This integration can map the near future of the smart homes, smart cities, and smart health, and so on. However, the intersection between the cloud, IoT, and big data analysis systems remain relatively intact. Generated services in a large amount of heterogeneity and fast data flow require assurance of real-time applications at quality service level, and one of the biggest challenges of this domain. As a case of remote healthcare, the quality of end-to-end service and issues related to resource management in COT ecosystems must be clear. So this is about the quality and reliability in healthcare systems, and we see that there are a lot of issues and concerns related to reliability and quality of service, because it is the matter of one's health. It is the matter of an individual's life, and so all the parameters, all the variables should be known to the system so that it can be analyzed and a proper diagnostic and a solution can be given. With this, I finish my talk. Thank you so much for patient hearing. I tried to be a little faster so that we are able to save time which we have lost in the afternoon. Thank you so much. Over to you.
Thank you, Dr. Manish Tiwari, for enlightening us with this good session. So any participant if want to ask something or say something? I think that nobody have any questions. The ma'am is asking something.
Sir, whenever you are talking about healthcare center quality of service, am I audible, sir?
Yes, I can hear you.
So in that case, suppose at quality of service, so for remote healthcare centers, what would be the measure of quality of service if some parameters like uh, blood pressure or something which is critical, so what would be the measure that they are considering as a quality of service?
See, basically the quality of service will not depend upon the parameter values. Actually, the quality of service is basically depending here on the will be depending here on the parameters infrastructure that is there to provide this particular service. For example, if suppose I am a doctor and I'm getting some information from a patient which is remotely located. Now, it is uh, it is the it is the question of the correctness of the data which is being received by me and which is again going back to the patient, so that a proper treatment can be given to him. So it is basically about the quality of the service that this infrastructure, whole IoT infrastructure, IoT in healthcare infrastructure is providing to both healthcare workers as well as to the patients. So first thing is that definitely this has to be very, very accurate. The sensors and all those things, IoT devices have to be very, very accurate. But at the same time, there are other parameters also, like I mentioned that network is also there, then cloud is also there. So all this infrastructure, its availability 24/7 by 365, and the correctness of flow of information from one end to other will be the parameters that will be adding or deteriorating the quality of service for this IoT healthcare systems.
Sir, actually, what I mean to say, suppose right now people are also sending their records, that is either CT scan reports or X-ray images
Hmm.
on WhatsApp media. But
Hmm.
already we have seen in Indian context, whenever
Hmm.
remote healthcare centers are there is
Hmm.
always a problem of network connectivity, low bandwidth ratio. The
Hmm.
bandwidth scenario is always people are facing in a remote area or
Hmm.
remote healthcare center. So at
Hmm.
that time, if one person is sending, suppose at 5 o'clock, and the
Hmm.
remote healthcare center is receiving that particular data not instantly, but
Hmm.
after a certain time when bandwidth is available properly, but when it is retrievable in a proper manner, means whatever report it has been sent, it has been retrievable at proper manner. So is it considered as a deteriorated of quality of service, or it would be considered whether they are getting the information in correct manner but in a delayed version?
Okay, ma'am, I got your question.
Hmm.
Actually, the infrastructure that we are using here for transferring the information, say CT scan or any other information from a remote location where the patient is located to a healthcare center. So actually, the infrastructure that we are using here is not meant for IoT healthcare. So here, this question of quality of service for IoT healthcare will not be there, because this particular thing is not there for IoT healthcare. I hope you are able to understand this, that we are sending the information on an inappropriate channel which is not meant for a particular kind of application. So there may be delays, and the system is not responsible for it because it is not meant for it actually. So if an IoT system, IoT system is causing this kind of problem, then definitely it is low quality of service.
So, what would be the possibility of improvement of quality of service if this kind of scenario, because bandwidth is not in our hand, as well as whatever transmission and reception media is there, that is also not in our hand. That is, one is using very advanced smartphone technology, other is using simple technology. So, whenever you are making a setup of IoT system, if as a engineer, if we want to establish one secure IoT healthcare center which will maintain quality of service, so what would be the important parameter, important thing that we will have to consider before establishing?
Installation of a backbone. The
Okay.
communication channel has to be very, very strong and strong, because it is all about the flow of information from one place to another. You can have locally installed sensors very good. You can have locally installed decision making systems very good, computers, servers, cloud, whatever. But if you do not have a good communication channel, that will be a bottleneck for the whole system. So that is one of the major things which has to be good to to guarantee a good IOMT system.
Okay, thank you, sir.
Anybody else? So thank you, Dr. Manish, for such wonderful explanations. Anybody else, if have any query, may please ask. Otherwise, we all, on the behalf of participants, also on behalf of my institute, I thank Dr. Manish for joining us. And I also thank all the participants for joining us in this evening session, which was not earlier scheduled. So thank you very much. Thank you, Ma'am Ketaki, also for asking some questions and making this session interactive. Thank you very much. Thank you, Manish, sir.
Thank you, Dr. Agrawal, for inviting me, and thanks to all the audience for such a patient hearing. And you are just a wonderful audience. I'll be happy to see you in person. Thank you so much.
Thank you, sir. Thank you. Thank you, everyone. So we will meet tomorrow at 10 o'clock in next session. Thanks all. Thank you, sir. Thank you, Dr. Manish Tiwari.
Thank you, sir.